NASA STEM Engagement and Educator Professional Development Collaborative logo. Welcome to NASA STEM EPDC Quick Bits Big Ideas in Science content. NASA STEM Engagement and Educator Professional Development Collaborative provides NASA resources and STEM strategies for STEM engagement. In this series, we intend to reach educators, parents, and caregivers to quickly explain a specific big idea in STEM. We will introduce a NASA example of how this idea is applied in the real world, and finally, we will demonstrate step-by-step how to lead this activity at home or in the classroom with your students. You might invite your students to watch with you at that time. We invite you to join us as we learn more from our specialists. Let's get started. NASA EPDC Specialist Stephen Smith at Johnson Space Center.
Today's activity is one of 5 activities that accompany the book Discoveries at Willow Creek. This book is part of a series created for the Elementary Globe site that follows the exploits of the Globe Kids or the Globe Science Club. In this book, the Globe Kids find out that Willow Creek looks different than it did the last time they visited. In this book, the students make observations, they take measurements, they look at animals and look at how those animals are adapted for their aquatic environments. They learn how to use tools for making scientific observations as well. To really get your kids out into nature and doing real hands-on science, I selected the third part of the activity, Water Wonders. This is the optional field trip and can be done with a set of materials that I think you are most likely to have available, and it can be done in a single afternoon. The big ideas we'll be covering are hydrology, or the study of liquid water, and macroinvertebrates, or animals large enough to see without a microscope that lack a backbone. The Water Wonders activity covers a wide range of standards from both Next Generation Science Standards and the Common Core Math and ELA content and anchor standards. This activity covers Earth Science Standards on natural resources, Life Science Standards on structure and function, and interdependent relationships in ecosystems. It touches on science practice standards of planning and carrying out investigation, including reading and comprehension, counting, measurement, and data standards as well. It also includes a wonderful glossary, which I've included for you here, that covers words like condensation, evaporation, groundwater, hydrologic cycle, and macroinvertebrates, which we've already talked about and we will definitely talk about more later, precipitation, runoff, surface water, transpiration, and watershed. Our Earth is a system, or rather a system of systems. There are 5 smaller systems, or spheres, that make up the larger global whole. These include the lithosphere, which is the rocky parts of the Earth, including lava and magma flow, the biosphere, or the web of all living things on our planet. The final 3 all have something to do with water in one of its 3 states. Solid water, or ice, on Earth is studied as the cryosphere. Gaseous water is included with important gases such as nitrogen, oxygen, and ozone into the atmosphere. And finally, the liquid water is the hydrosphere. As you can see in this image, taken from Apollo 17, which was our last trip to the moon, liquid water covers about 70% of the Earth's surface, being mostly found in our oceans. Only a very small percentage of that is freshwater, about 2.5%, and only 1% of that is accessible to us as surface water. Water moves through the larger Earth system. That movement is called the hydrological cycle, or more simply, the water cycle. Water moves to the atmosphere through evaporation and transpiration from plants, condenses there, and then falls back to Earth as precipitation, only to gather and restart the process. The second part of our big idea for this activity is macroinvertebrates. As we've said before, this term refers to animals that are large enough to see with the naked eye that also lack a backbone. Now, this may seem like 2 very different things, but remember, our planet is a giant system of systems, all interconnected, each part affecting the other parts. So scientists study these animals to help them understand the health and conditions present in aquatic systems. Different types of macroinvertebrates have different tolerances for things like temperature, pollution, salinity, which is the amount of salt in water, the movement of the water or flow of the water, and many other factors. The word for this is biomonitoring. The relationship between the water and the animals that live in it are what we will be looking at in this activity. NASA has a long history with the study of Earth science. We study the Earth as part of the solar system, but also as our home. Earth Day was started by a single photograph taken during Apollo 8, where the astronauts who had gone out to the moon for the very first time turned around and looked back at our home planet. That photograph so captured people's imagination that Earth Day, the Environmental Protection Agency, and several other things can be tied back to that moment in history. GLOBE is an acronym that stands for the Global Learning and Observations to Benefit the Environment program. This is an international science and education program that was started really to create a worldwide community of students, teachers, scientists, and citizens who all work together to better understand, sustain, and improve the Earth's environment at a local, regional, and global scale. We partner with several other organizations like NOAA, the National Oceanographic and Atmospheric Administration, and other people in order to better understand our Earth. My NASA Data is a repository for the satellite data from instruments that are looking back at our planet, taking measurements of our atmosphere, the biosphere, the geosphere, the hydrosphere, the cryosphere, and Earth as a system. This activity is closely linked to our work with the Earth-facing satellites, and GLOBE is just an extension of all of that work. NASA is also interested in better understanding the Earth and its systems, so that as we explore other planetary bodies, like the Moon and the planet Mars, we can better understand the processes that have shaped them, and where we might find resources in the future as humans expand our presence in our own solar system. We'll be doing the optional field trip, which is part 3 in the Water Wonders activity set. The purpose is to introduce hydrology, or the study of water, and macroinvertebrates, and how those macroinvertebrates live in their aquatic environments and what they tell us about the water quality and different things that are going on. But before we begin anything else, you have to read the book. In the book, you'll go on a field trip with Simon, Anita, Dennis, and their classmates, and you'll find out what happens when the kids revisit Willow Creek. Gasp! Something is different. What has happened? Well, the kids will have to use their observations and data they collect to discover the truth. Dun dun dun! Now, if you're following along, this might be a good place to pause the video and go read the book.
Did you read Discoveries at Willow Creek?
Welcome back. The written activity gives you a pretty straightforward set of directions. I hope you notice that the very first direction is about safety. Now make sure that you know what hazards may be in the area that you'll be working in. Water attracts wildlife, so always be aware of your surroundings and respectful of any wildlife that you may encounter there. Gather your materials, and when you get to the stream or the pond or the puddle or the ditch or whatever you happen to have available to you, the first step is to use your senses. Really listen and look and smell and get a feel for what's going on in that environment, and record those before you start dipping out critters or measuring temperature or anything like that. Now, step 4 says to wade into the stream, but you make that decision. If it's safer to work along the banks of a pond or a lake, then do that, absolutely. So use your judgment, be careful, but dig in there. When you start pulling species out, make sure that you pay attention to whether these are in fact aquatic invertebrates or they are vertebrates. So small tadpoles or fish may get caught in your net also. Those are not the invertebrates we're looking for. Those are vertebrates. They have backbones. If you have the ability, if you maybe have pool testing equipment that can test pH and different things like that, then absolutely bring those. The more data you can collect, the better. Then after you get back, have your students write a little bit or draw a picture about what they saw, smell, heard, or felt on the trip. And you can even go a little bit further. We have a wonderful freshwater protocol. I marked off where you can find it on the page right here with this red arrow.
Now that we've read through the instructions, let's go to the pond.
So all that was left for us to do was to grab our list of the different invertebrates we might see, to grab our materials, and you can see here we selected a bunch of different ones, and go down to the pond. As you can see, I'm really trying to disturb the bottom. I'm trying to mix up as many things as I can so that I get the best chance of catching something cool. If you look closely, you can see the macroinvertebrates moving on the net. I scooped up a bit of water out of the pond so that I could wash off the net and really get a chance to see what I had caught. After looking under the magnifying glass, we figured out that we pretty much caught water boatmen. Those are really cool. They tell us a lot about the pond. There is a little mistake here. They measure them in centimeters. It should have been millimeters. These are tiny little creatures. I'm here with my son Sebastian, who helped us with this and did the activity with us. I had him draw this picture for you to kind of go along with it to show you, so I'm going to have him sort of explain what's in the picture.
We are by our pond, and it's surrounded by lots of land, and we always have a gate there to keep people out from that one area. It's breezy and cloudy. Dad is holding up the jar with all the little critters in it. While Amy's filming, I drew the rocks where the baby alligator, Speedy, always likes to hang out.
Okay, but we were really careful.
Yeah.
Made sure that there was nothing that was going to eat us. But Speedy's not very big. And
yeah.
He kind of runs
and
away.
I even drew the little lush area.
Oh, nice.
Where we got all the little critters.
Wonderful. And then what critters did we find?
We found some mosquito larvae.
What was the one that we saw the most of? 2 words.
It's a water boatman.
Perfect.
Water boatman.
Water boatman. And you draw a great picture of a water boatman for us. It looks wonderful. Thank you so much for sharing with us.
You're welcome. Bye.
I hope you had fun and learned more about the hydrology of your area and the aquatic macroinvertebrates that live there. Now you can go deeper. You could look up the animal you found and see if you can figure out what they tell us about the water you found them in, or do any of the extensions you see here for younger or older students.
For younger students, draw a picture or write a few sentences about the animal. For older students, test pH or oxygen levels, or use a field guide to identify unknown macroinvertebrates.
Today's activity is part of NASA's larger efforts to make our many free and engaging resources more easily available to you. We created a resource called NASA STEM at Home for students. Our specialists have worked hard to curate activities and resources that you can use at home with materials that should be readily available. You'll find special pages for K through 4, 5 through 8, and 9 through 12 at nasa.gov/STEM.
Thanks for watching this NASA STEM EPDC Quick Bit. Don't forget to check out the description below for more information and links. www.txstate-epdc.net. Logos for the Texas State University LBJ Institute for STEM Education and Research, NASA STEM Engagement and Educator Professional Development Collaborative, and NASA Partner. The material contained in this document is based upon work supported by a National Aeronautics and Space Administration, NASA, grant, or cooperative agreement. Any opinions, findings, conclusions, or recommendations expressed in this material are those of the author and do not necessarily reflect the views of NASA. Images and footage courtesy of NASA. Images and footage used under licenses from Shutterstock.com and Envato.